Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the Zener diode. So Zener diode is a diode which is just a normal diode that is used in reverse biasing. And this Zener diode is operated in reverse breakdown region. So you can see the symbol of Zener diode, and this symbol is different from the symbol of normal diode. But it doesn't mean that Zener diode is something else. In fact, I am again telling you that Zener diode is just a normal PN junction diode which is operated in reverse biasing in reverse breakdown region. So this is a Zener diode, and the reverse breakdown voltage of Zener diode can be controlled by controlling the doping concentrations, and it can vary up from 2 volt to 200 volt. Now if we will increase the doping concentration, then you know that the depletion region width will decrease and it will easily break down, which means that on increasing the doping concentration, the reverse breakdown voltage decreases. So we can say that the doping concentration is inversely proportional to reverse breakdown voltage. So if we increase the doping concentration, then the junction will easily break down because its width is very low. And if we decrease the doping concentration, the width of depletion region increases and its breakdown voltage also increases. So we can say that if the doping concentration is low, then the reverse breakdown voltage will be higher, and if the doping concentration is higher, then reverse breakdown voltage will be lower. Okay, now at a very high reverse voltage, the electric field which is produced inside the diode is exceeding this value, which is 3 into 10 raised to power 7 volts, and due to this, large number of electrons breaks their covalent bonds and becomes free, and therefore a reverse current increases in the diode sharply, and this increase in the reverse current without any increase in the voltage is called as Zener effect. Now obviously this current is not increased due to the increasing voltage. In fact, this current is increased due to the increase in the availability or the number of free electrons and holes. Therefore we can say that at almost constant voltage, the current increases abruptly, and this effect is called as Zener effect. And there is another effect which we have already discussed in reverse biasing, which is avalanche effect. Now in this avalanche effect, when these electrons are which are produced in Zener effect, when these electrons are accelerated by the high electric field which is applied in the reverse biasing, then they ionizes the atoms which are occurring in its path and due to collision, and due to those ionization, more electrons are produced which are again accelerated at high electric field, which again ionizes more number of atoms, and this chain reaction occurs, due to which a very large number of free electrons are produced in the diode, and this is called as avalanche effect because a kind of avalanche occurs in the diode, avalanche of electrons. Now Zener effect is predominant at the voltages which is less than 4 volt, reverse voltage we are talking about, and avalanche voltage predominates at a voltage which is more than 6 volt, and between 4 and 6 volt both effects are present. So in reverse biasing, the Zener effect, Zener voltage is almost constant, and the current increases to a very high value for a constant value of reverse voltage. Therefore the Zener diode can be used as voltage regulator in many purposes. So let us discuss a voltage regulator. So let us discuss that this is a unregulated power supply, in which this is a DC power supply which we have obtained from rectifier, and this is like that. So let us assume a scenario that this peak value is 10 volts, and this value is 8, in fact let's suppose 5 volts. So there is a fan which we need to operate across the load resistance, ceiling fan, which cannot bear a voltage which is greater than 5 volt. Because if a voltage which is greater than 5 volt would be applied on this fan, then its motor would be burned. So we have to avoid the voltage across this fan above the 5 volt. So what we have done, we will be using a Zener diode in parallel to this load resistance. Now load resistance is used to obtain the output. So we are connecting any appliance which we have to use in the parallel to the load resistance, and a Zener diode is connected in parallel to the load resistance. Now you should always remember that you have to connect the Zener diode in reverse biasing only. So if this polarity is positive, this polarity is negative. So I have connected the N terminal of the diode with the positive polarity and P terminal of the diode with the negative polarity. So this is connected in reverse biasing. Now I have selected the Zener voltage as 4.8 volts. Okay, so to avoid the 5 volt level. So at this voltage, when this power supply will come, so at this voltage, Zener, as soon as this voltage will cross 4.8 level, Zener diode will become breakdown, and before 4.5, now let us talk about the voltage which is less than between 0 to 4.8. So if the input voltage, which is the voltage across this Zener diode, is less than 4.8, then it will offer very high resistance, because you know that in reverse biasing diode offers very high resistance, and due to that high resistance almost all the current will flow through the load resistance, and a voltage will be developed which can be used to operate the ceiling fan. But as soon as the voltage will go up above this value, V is greater than 4.8, when V will be greater than 4.8, then at this value what will happen, that the Zener diode will break down, and the voltage across this Zener diode will become constant, which is Vz, which is 4.8 in this case. Now any current which is going to a large value, let us suppose a scenario that this load resistance is RL is 48 ohms. So we know that if this voltage becomes 4.8, then this output voltage will be constant also. It will be equal to 4.8 volts, and this will be equal to IL into RL. So IL will be 4.8 upon 48, which is 0.1. So for any current which is coming here, let's suppose this current is 10 ampere which is flowing due to uninterrupted unregulated supply. So it will be ensured that the current flowing through the load resistance will be 0.1 only, because the voltage across load resistance is constant. So the current flowing through the load resistance will change accordingly, but voltage will remain constant. So any extra current which is 9.9 in this case, 10 minus 0.1, will be bypassed through this Zener diode, because it will allow any value of current at this voltage to flow. So you can see that for any value of voltage which is above this level, the Zener diode will maintain a constant voltage across this output, and any extra current which is flowing through the circuit will be bypassed by Zener diode. So in this way you can use the Zener diode as voltage regulator. Okay, so this is a very important use of Zener diode. And now let us talk about the VI characteristics of Zener diode. So as we have already discussed earlier in this video, that Zener diode is nothing but it is a simple PN junction diode which is operated in reverse biasing and in reverse breakdown region. So this will be the VI characteristic of Zener diode, in which we will say that the Zener diode will be operated in the region which is beyond this reverse breakdown region. So this is the VI characteristic of Zener diode. So this was the Zener diode, and in the next video we'll be bringing photodiode. Thank you.